So our main reason for talking about logic and doing these truth tables is to talk about arguments. This is something you do in your day-to-day life. You make an argument for some kind of side. You're making an argument in your English classes for this thing to be true. What we want to make sure is when I'm putting these different hypotheses or premises together and I make a conclusion as a result of that, I'm making something that makes sense and I'm being truthful the entire time. Because there's still a possibility if you think about your argument, the things you're saying could be true or could be false, but no matter the combination of that, you want to make sure in the end you're not contradicting yourself. So a symbolic argument is going to consist of a set of premises and a conclusion. The premises you can kind of think of as hypotheses. It's another way to think of it. So when we're given an argument, the argument is going to be valid when its conclusion necessarily follows from a given set of premises. So no matter the truth value of the premises, your conclusion is going to occur. If that doesn't happen, then an argument is either invalid or it's a fallacy. Okay. So what I'm going to do is I'm going to start with an argument. We're going to turn it into symbolic form. This argument will hopefully make sense just from the natural premises of what has to happen. And then we're going to show that we're going to make a truth table. And yes, it's necessary that this is going to follow. So we're going to consider two statements. The first is our first premise. If we go to the movies, then I buy popcorn. Premise 2 is we go to the movies. If I'm now saying these premises together, the natural conclusion would be I buy popcorn from this. Okay. So if we go to the movies, then I'll buy popcorn. Then we go to the movies. So the conclusion is I buy popcorn. So I'm going to call these statements P and Q. P is we go to the movies. So this is also statement P right here. And then Q is going to be the phrase I'll buy popcorn. And so that is our conclusion. So the way we're going to put this in symbolic form is premise 1 is that conditional statement. So if P happens, then Q happens. Premise 2 is the statement P. And then we usually like to use a little bar underneath this, but really just under this part. Then our conclusion occurs. And the conclusion in this case is Q. So the way we write this is we use these 3 dots and then Q. These 3 dots really stand for the word therefore. Okay. So the way you can look at this argument is if this stuff happens, then the conclusion must follow. So really every single argument we're going to be able to turn into a giant conditional statement. If the premises hold, then the conclusion holds. Okay? So every argument is going to be if the premises hold, then the conclusion holds. Okay. So turning this into a single symbolic argument, we can really do if premise 1 and premise 2 happen, then the conclusion happens. So again, a giant if-then statement. Okay? So if the premises happen, then the conclusion happens. Okay? So the premises I have to write as premise 1 and premise 2. So if premise 1, which is if P and Q, then Q, and premise 2 hold, then the conclusion holds. Okay? So I'm turning this argument into a single symbolic phrase that I want to determine the truth value of. Okay? So we can ultimately construct a truth table to see, is this statement always true? And I'm going to move this down here because we're going to need a giant truth table. Because again, the phrase, we go to the movies, could be true, could be false. The phrase, I'll buy popcorn, could be true or could be false. But this argument, I always want to be true. Okay. So starting out, we've got P and Q. So we're going to go through all of those possible truth combinations. Okay. Now I need a column for premise 1. So I'm going to put that in its own column. Okay. Premise 2 is already in its own column. That's right here. Then I need a column for premise 1 and premise 2 together, their truth value as an and. Okay. So that's really this entire starting statement. So if P, then Q, and statement P. So premise 1 and premise 2. And then I've got all of this. I've got statement Q's values. We can do this entire argument. So this last column is the final argument if premise 1 and premise 2, then the conclusion. Okay. So we've got the starting premises followed by the conclusion. Okay. So the headers are going to take up much more than the actual boxes themselves. So I'm going to start with finding the validity of premise 1. So P's values go in the corner, true, true, false, false. We've got the conditional statement. And then Q's values are true, false, true, false. So searching for that bad case, that's right here. This is the only time the first premise is false. Everywhere else is true. Okay. So I've got the truth values of if we go to the movies, then I buy popcorn. This is the only case we went to the movies, but I didn't buy popcorn. So it's a false statement. Now my truth values for we go to the movies are right here. So I'm combining the two premises. If we go to the movies, then I buy popcorn, and we go to the movies. So in the front, I'm going to put the truth values of premise 1 in the corner. Okay. So these values are true, false, true, true. The operation we're doing is end, premise 1, end. Then the values for premise 2 are just P's values. So that's true, true, false, false. Okay. So I'm seeing when are both of the premises true, and that's really only this first case. In these other cases, premise 1 and premise 2 are not both true. Okay. Now I want to see what is the validity of my final statement? So if premise 1 and premise 2 occur, well, in this case, premise 1 and premise 2 did occur, but it did not for these other scenarios. Then we're seeing, did I buy popcorn? So I need to put Q's values, which are all right here. So that switches true, false, true, false. So for the conditional operation, I'm seeing, do I have that bad case? Here's where both the premises happen. We went to the movies, then I bought popcorn. We went to the movies. So in the end, I did buy popcorn in this scenario. I was truthful. In these three situations, premise 1 and premise 2 did not occur. So the conclusion really doesn't matter. I didn't lie by what I said, so I end up with a true statement in the end. Okay? So no matter what, my argument is always truthful. So because of that, this argument is valid. So again, I'm searching in the end, is that final statement always true? Okay. So let's try really just a bunch of examples of these. Again, if one of these is false, the argument is invalid. Everything has to be true. So we're going to try this next one. We've got two premises followed by a conclusion. So again, I want to put this in symbolic form to start. So I want a single statement. Okay. You can break it down in words if you need to happen, but you should be making a giant conditional statement. Okay. So that starting piece has to be if premise 1 and premise 2, then this conclusion. So if premise 1, which is P or Q, and premise 2 happen, then the conclusion follows. Okay. So writing that in words for you just so you have it. If premise 1 and 2, then the conclusion. Okay. So you're always going to write this as a giant conditional. You've got premise 1 and premise 2, then the conclusion. If there's three premises, premise 1 and premise 2 and premise 3. That would be a lot though. Okay. So I need to go through and I need to figure out the validity of this statement. So I've got to take it piece by piece. I always start inside those parentheses. So before I can do any of these or figure out this end, I do need to figure out the truth value of P or Q. So this is a truth value of premise 1. Then I need the values of premise 2, and that's just not Q. Now we're combining them together. What's the validity of premise 1 and premise 2? So this is the truth value of P or Q and not Q. Okay. So I've got the truth value of this full statement. I have P's values way back at the beginning. So I don't need a separate column for the conclusion because those values are back here. So now we can figure out the entire argument. So if premise 1 and premise 2, then the conclusion. Okay. So going through, we have the same starting values as always. Okay. Starting out with premise 1, P or Q. Again, just to keep track of everything, here's P's values. We're doing or, and then Q's values. When you're doing or, you need at least one T. So P or Q is true, yes. P or Q is true, yes. P or Q is true, yes. But then unfortunately here, P or Q is not true. Now finding the values of premise 2. That's just negating Q. So these are all going to flip. False, true, false, true. Now we can find the validity of premise 1 and premise 2 together. So premise 1's values are true, 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 false. We're doing the AND operation. Premise 2's values are false, true, false, true. When I'm doing AND, I need them both to be true. So this is not both true. They are both true. Not both true, not both true. Okay. So this is that combination for those premises together. So now I'm searching for the very end. If the premises happen, then does the conclusion follow? So my premises together have the values false, true, false, false. We're doing a conditional statement here. And then I need P's values, which are true, true, false, false. Because that's the ending statement. So I'm searching for the bad case. When it starts false, there's absolutely no issues. True is the only possible way you could have a bad case, but I don't have that true to false. So in the end, these are all true statements. Okay. So because that happens, this argument is valid. I'm never going to say something that is false. Okay. Let's try another one of these. We ultimately are going to do 3 of them. You're going to see the next one's going to be quite a doozy because it's got 3 statements, P, Q, and R. But at least for this one, I'm just going to have 2 statements, or 2 premises, 2 statements. So my argument won't be as tedious. So putting this in symbolic form to start. We need to go ahead and say premise 1 and premise 2. So if premise 1 and premise 2 happen, then the conclusion has to happen. And unfortunately here, my conclusion is a statement I do need values for. So starting out dealing with A and B, running through their possible combinations, same as always. We now can go piece by piece. So we'll start out inside the innermost set of parentheses. We're going to find premise 1. Then we're going to go ahead and find the values of premise 2. So that is, what are the values of not A? Now I have both of these. So we can do this entire first starting statement, which is premise 1 and premise 2. Okay. So before I can do this conditional statement, I need to figure out what are the values of not B. So I need a column for that. Now I've got the starting, then the conclusion. We now can do this entire symbolic argument. So if premise 1 and premise 2, then the conclusion follows. Okay. All right. So we are set now to go ahead and look at this truth table. So for the first one, just to save some time, we are just doing the conditional with if A, then B. This is that only bad case, true to false. So this one's false, but the others are all true. Then I have to find not A, so I need to flip these values. So that is false, false, true, true. For the next column, I'm doing premise 1. Those values are true, false, true, true. And is the operation premise 1 and the values of premise 2, which are all of these ones here. So doing that end operation, this is one case, and this is the second where they are both true. So this is true, but these are false. Okay. Moving on to not B, I'm going to go ahead and flip these values. So that becomes false, true, false, true. So for my final argument, I'm really just doing if premise 1, then premise 2, which is right here. So the premises together have the values false, false, true, true. The conclusion has the values false, true, false, true. So I'm searching in that conditional phrase for that bad case, and unfortunately, I do see it here. So the premises were true, but the conclusion was not. So I have made a false statement here. Every other statement is fine, but I do have a false one. So because I didn't always say something that's truthful, this argument is considered invalid or a fallacy. Okay. All right. So on to second to last one. This one is definitely the most complicated of them all because it's got statements P, Q, and R. So 3 statements. Remember, it has 8 possible combinations for truth values. So before I do that, I'm going to go ahead and put this in symbolic form. So I still do the same thing. Going to need lots of room for this one. I need a giant if-then statement. I need if premise 1 happens. So if premise 1 and premise 2 occur, then the conclusion has to follow. So the conclusion in this case is a compound statement, P or R. Okay. So in order to get to this end step, I need premise 1's validity, which is P if and only if Q. I need premise 2's validity, which is Q and R. Then I need premise 1 and premise 2 together. Before I can get to the conclusion, I need the truth value of the conclusion itself. And then finally, I can do this giant if-then statement. Okay. So these are all the headers and columns that I need to find to get to this end argument. So we got a giant truth table here. So starting out, I got to figure out all those combinations. Again, I'm going to start by running through those options with Q and R. So the same 4 options again. And then I make P true for all of them. Run through the same 4 options a second time. And then I make P false. Okay. So I need to start with this if and only if. So I'm going to copy P's values followed by Q's values. So P is true, 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 false, 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 false. We're doing double-sided arrow. And then copying Q's values, those are true, true, false, false, true, true, false, false. So the biconditional is true when they match. Here they match, they match, they don't match, they don't match, don't, and then finally they do match. So these are the truth values of my first premise. Now I want to do the truth values of Q and R. So I'm using these 2 columns. Q's values are true, true, false, false, true, true, false, false. And then we're doing end. R's values alternate, true, false, true, false, true, false, true, false. So for end, I need both to be true. So I'm asking, is Q and R true? In this case, yes, but here, no. They're not both true, not both true, not both true. Yes, they're both true. No, they're not. No, they're not. No, they're not. Okay. Now I can go through and do premise 1 and premise 2's validity. So starting out, premise 1 has these values. So we copy them in the corner. True, true, false, 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 true, true. The operation we're doing is end. And then we need Q and R's values, which are all right here. So that's true, false, true, false, true, false, true, false. Okay. So again, for end, I need both to be true. Yes, they're both true. No, they're not. No, they're not. No, no, no. Oh, I copied the wrong letter here. Super easy to do that. As you can see, this should be an F. No, they're not. And no, they're not. Okay. All right. Now we can move on to the conclusions validity. So I need to figure out the values for P or R. So I'm going to copy P's values or R's values. So P goes true, 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 false, 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 false. We're doing the OR operation. R's values alternate, so true, false, true, false, true, false, true, false. OR needs one T to be truthful, so yes, 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 no, yes, yes. So that's the truth value of the conclusion. Now I can make this argument, which again, these are the conclusion value or the premise values. These are conclusions. So I'm really just doing an arrow operation here. But again, I can go ahead and copy these down. So here is the values of the premises. True, false, and then really all falses down. We're doing a conditional statement. And then I need to put the values of the conclusion, which is right here. So that's true, 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 false, true, true. So I'm searching for that bad case, starting true, leading to false. Thankfully, I only have a single case that starts with true and it leads to true. So this is good, and so is every of these other situations because you are starting false every single time. So in the end, I'm making a statement that is always truthful. This argument is valid, okay? So I've got one more example that I'm going to do, and for this one, the argument's given to us in paragraph form. We're going to have to pick it out based on two different statements that we see, write the argument up, put it in symbolic form, and then do a truth table to test the validity. So we're going to translate this into symbolic language and determine if the argument is valid. So we've got one statement: a tiger is a cat and a giraffe is not a dog. Then we've got another statement: a tiger is not a cat or a giraffe is not a dog. Therefore, which means my conclusion, a tiger is not a cat. Okay. So a lot going on, but I've got two statements. I've got a statement P, which is a tiger is a cat. And then I've got a statement about a giraffe is a dog. Technically, you could use giraffe is not a dog as a statement Q, and its negation would be then a giraffe is a dog. But purely because of the word not being in there, we like to associate that as not Q. So Q, I'm going to make the phrase a giraffe is a dog. So I'm going to start by putting the argument just as it's normally set up, where I've got my premises followed by my conclusion. Okay. The first sentence, a tiger is a cat, that's P, and is going to be that upside down V. A giraffe is not a dog is not Q. The second sentence is a tiger is not a cat, so that's the negation of P, or is symbolized with a V. And then a giraffe is not a dog is not Q. The conclusion is a tiger is not a cat, so the conclusion is not P. So that is my argument. So putting this in symbolic form, we've got premise 1 and premise 2. If those happen, then the conclusion occurs. Okay? So I need a pretty large truth table. Doesn't need a ton of columns actually, but I need just space because these are long sentences. Okay. So I've got the statements P and Q. Again, they have the same 4 possible combinations. Okay. I'm going to need the negation of both of these here before I can do these ands and ors. So I might as well, in this one, just do them right at the beginning. It wasn't necessary all the way kind of back up here. You could do swapping these and find the negation first and then do everything, but it's really up to you what order you want to do it in. Okay. So I'm going to find these as well because it just flips everything. So not P is false, false, true, true. Not Q is false, true, false, true. So I'm going to start with the first premise, which is P and not Q. Then I can find the second premise, not P or not Q. Okay. Then I'm going to find premise 1 and premise 2. We then have the premises. I have a column already for the conclusion. We now can do the full argument, which is if the premises then this conclusion occurs. Okay. So starting with premise 1, I've got P and not Q. So I'm going to copy those values in. P is true, true, false, false. The operation is and. Not Q is false, true, false, true. Okay. So and needs both to be T. So no, yes, no, no. Then moving on to premise 2, it's not P or not Q. So here, this is not P is false, false, true, true. We're doing or. Not Q is false, true, false, true. Or needs 1. So the answer here is no, yes, yes, yes. Now I'm looking at premise 1 and premise 2. So premise 1's values are false, true, false, true, false, false. And is the operation I'm doing now. Premise 2 values are false, true, true, true. So and needs both to be true. Answer here is no, yes, no, no. Okay. So to go to my final statement, these are the premises together. So those values are false, true, false, false. Okay. Then I'm doing the conditional statement. And then I want to put not P's values. So I'm going to copy these down, which are false, false, true, true. So searching for that problematic case, I do have it. I start true and lead to false. So this is a false statement, which immediately tells me my argument is invalid. Considering though these other cases, these are true. But I do have a single value that is not true, So overall, this argument is invalid. Okay. So you can see these take quite a while. Take your time. Again, just dissect it piece by piece.